Hello everyone, let us discuss a topic on stack and its operations. Introduction to stack and its operation. A stack is a data structure that allows from the last in first order principle. First out principle. It consists of the two main operations: push, inserting an element, and pop, removing an element. Other operations include pick, leaving the top element and is empty, checking if the stack is empty. Push operation. Push operation adds an element to the top of the stack. It increases the stack size by 1. The added element becomes the new top element of the stack. Push pop operation. Pop operation removes the top element from the stack. It decreases the stack size by 1. The element that is popped is permanently deleted from the stack. Peak operation. Peak operation allow us to view the top element without removing it. It does not modify the stack size or the top element. This operation is useful to checking the value of the top element. Is empty operation. The is empty operation checks if the stack is empty. It returns true if the stack has no elements, otherwise false. This operation helps in handling the stack underflow situations. Stack implementation. Stack can be implemented using the arrays or the listed linked list. Arrays provide a constant time access to the elements. Linked list provides dynamic memory allocation and flexibility. Array implementation. In array implementation, a fixed size array is used to store the stack elements. The top element is tracked using an index variable. Array implementation has a fixed minimum capability. Array implementation pros and cons. Pros: efficient access to elements, simple implementation, and no memory fragmentation. Cons: limited size, potential overflow, and wasted memory if the stack is full. So, what are the advantages are? This is a convenient way of storing a known number of elements in the same type. The memory allocation for the data is done frequently and does not engage any extra memory space. Accessing the array using their index values is faster method. It allows the matrix data elements to be stored in the multidimensional array. Disadvantages. The array allows storing only a fixed number of elements as per the size defined initially. If the actual number of elements is less than the declared of the size, the extra memory space already allocated remains unutilized. Handling with the same type of data also causes the limitation of times. Insertion or deletion of the records from the array not convenient and would not be the time consuming. Linked list implementation. In linked list implementation, each element is stored in a node. Each node contains the data and a reference to the next node. The top element is the head of the linked list. Linked list implementation pros and cons. Pros: dynamic memory allocation, no size limitation, and efficient memory usage. Cons: slightly slower access time, extra memory for storing references, and potential memory fragmentation. Time complexity of stack operation. Push, pop, peak, and is empty operations have the time complexity. These operations do not depend on the size of the stack. Space complexity of stack operation. The space complexity of stack operation is O. It depends on the number of elements stored in the stack. Common applications of stack: function call management, recursion, backtracking, expression evaluation, infix to postfix conversion, calculator. Real-life examples of stack: browser history. Each visited web page is added to the stack. Call stack. Function call and local variables are stored in the stack. Plates in cafeteria. The last plate put on the stack is first on to be taken. Stack overflow. Stack overflow occurs when the stack capacity is exceeded. It can happen in both array and linked list implementation. Proper size allocation and error handling can prevent the stack operation and overflow. Stack underflow. Stack underflow occurs when the pop operation is performed on an empty stack. It can result in a runtime error or an execution exception. Checking the stack emptiness before a pop operation avoids the stack underflow. We come to the summary of this topic. A stack is a data structure that follows the LIFO principle. Push adds an element, pop removes an element, peek views the element and is empty checks if the stack is empty. Stack implementation can be done using the arrays or the linked list. Array implementation has a fixed size and offers efficient access. Linked list implementation provides dynamic memory allocation and flexibility. Stack operations have constant time complexity and space complexity depends on the number of elements.